Throughout the early 2020s, an unusual medical phenomenon began appearing in patient support groups. To treat the debilitating brain fog and fatigue of long COVID, some patients have turned to simple transdermal nicotine patches. This creates an immediate sense of cognitive dissonance. We are conditioned to see nicotine as a toxic, addictive driver of disease. Yet here it is being used to investigate a path toward recovery. But the plant itself, Nicotiana rustica, has a history that predates modern cigarettes by thousands of years. For indigenous populations across the Americas, this was a medicinal botanical used to treat wounds and manage respiratory conditions. The botanical's medical history was largely obscured during the industrial era. As tobacco was mass-produced and chemically altered for addiction, the specific biological properties of the molecule were lost to the narrative of combustible smoke. Modern citizen scientists are now looking past that commercial history. By isolating the molecule, they are reclaiming a biological tool to see if it can regulate an immune system that has lost its internal balance. To understand the recovery, we have to look at the cholinergic anti-inflammatory pathway. This is essentially the immune system's primary braking mechanism. Macrophages are covered in specialized docking sites called nicotinic acetylcholine receptors. The alpha-7 subtype acts as the off switch for inflammation. When natural acetylcholine binds to these sites, it signals the cell to stop producing inflammatory markers, preventing healthy tissue damage. The SARS-CoV-2 spike protein complicates this process. Structural analysis shows that a specific sequence in the spike mimics the behavior of certain snake venom neurotoxins. This venom-like spike targets the same docking sites. By physically occupying the alpha-7 receptors, the virus prevents the body's natural acetylcholine from sending its calming signal. With the docking sites occupied by the virus, the immune system loses its ability to brake. This leads to the persistent, hyperinflammatory state known as a cytokine storm, a suspected driver of long COVID symptoms. The viral spike does more than sit in the way. It warps the receptor's structural integrity through allosteric modulation. Once warped, these receptors are pulled inside the cell and internalized, effectively removing the immune system's control panels from the surface entirely. This is where the transdermal nicotine patch comes in. By introducing a steady, low dose of isolated nicotine into the bloodstream, researchers hope to stage a molecular intervention. This chart compares their binding strengths. Nicotine has a 30-fold higher affinity for the alpha-7 receptor than natural acetylcholine. Because it's mathematically more likely to win the docking site, nicotine physically displaces the virus, ejecting the spike protein and restoring the receptor's functional shape. By regaining control of these molecular switches, the immune system can finally re-engage its anti-inflammatory brakes. This provides a structural explanation for why some patients see their brain fog lift within days. It is vital to distinguish between the molecule and the delivery method. This is not an endorsement of smoking, which floods the lungs with hundreds of toxic chemicals that actively damage the vascular system. However, when isolated and controlled, nicotine serves as a highly specific biological probe that interacts with the deepest levels of our immune signaling. Right now, pharmacology labs are using the structural map of these interactions to develop new targeted compounds. They are looking for ways to trigger these same immune switches without the risk of addiction or cardiovascular stress. The objective is to stabilize the immune system and clear post-viral inflammation using the precision of nicotinic signaling, but via modern engineered medicine. These future therapies are being built on observations that stretch back to the Nicotiana plants used in ancient healing traditions. By looking past the modern stigma of the tobacco industry, researchers are finding that even the most controversial molecules can offer a template for recovery. It is a validation of the idea that nature's defensive compounds often hold the exact structural data needed to repair human health.